The Vajont Dam survived. Longarone did not. That is the contradiction at the center of this story. A concrete arch dam, 860 feet high, stood almost untouched in a narrow alpine gorge. Below it, a town was erased in minutes. The easy version says a mountain fell into a reservoir and made a wave. That is true. It is also incomplete. The harder question is why a disaster could move through so many warnings and still arrive with the reservoir treated as controlled. Why did the final safety number, 700 meters above sea level, become a kind of permission? And why did the record after the disaster have to admit human responsibility while the dam itself remained standing? To understand Vajont, do not start with the dam. Start with the empty space behind it. That space was supposed to become power. It was part of a hydroelectric network built for northern Italy after the war, a system of reservoirs, tunnels, powerhouses, and mountain water turned into industrial energy. The place looked made for a dam. The Vajont River cut through a steep limestone canyon just upstream of Longarone. The gorge was narrow. The walls were high. A thin arch could hold back an enormous volume of water with a relatively small face of concrete. That was the engineering argument. The geological argument was different. On the south side of the future reservoir stood Monte Toc. The name itself was remembered locally as the mountain that walks. That phrase is not engineering data, but local knowledge was pointing towards something the project would later measure in instruments. The slope was moving. The dam was not the weak object in the landscape. The mountain was. And the project slowly taught the mountain how to fail. Construction began in 1957. The dam was completed in 1960. It was a double-curved thin arch, one of the tallest dams in the world. In photographs from the period, it looks almost elegant. A white concrete wall drawn across a dark gorge. A promise that the valley had been mastered. But mastery is not the same as understanding. During construction and first filling, there were disputes over the slope above the reservoir. Some geologists and engineers warned that the mountainside might not be stable. There were fractures, there were shifts in the road, there was concern that filling the reservoir could weaken the slope. The warning was not invisible. It was distributed across reports, measurements, road cracks, and the memories of people who had lived under Monte Toc before the reservoir existed. Longarone was not an abstraction below the dam. It was a place with families, shops, hotels, workers, and children. The public list of the dead preserves names and birth years. Ansalute Gianmarco, born in 1963. Carrara Eugenia, born in 1963. Maier Gianella, born in 1963. Those names do not need invented scenes around them. Their presence in the list is enough. They show what the word downstream meant. In 1959, before Vajont failed, another nearby reservoir gave the project a warning in miniature. At Ponte Toc, a landslide entered the water and produced a wave. One person died. The event showed that a reservoir could turn a slope failure into a flood weapon. Therefore, Vajont managers had a real-world example. Not a theory, not a distant academic fear, a smaller version of the same mechanism. Then on November 4, 1960, Vajont produced its own warning. A rock slide of roughly hundreds of thousands of cubic meters entered the reservoir. The wave was small compared with what would come later, but it was large enough to prove the connection. Water level, slope movement, and wave risk were now linked inside the actual basin. The response was not nothing. That matters. The project lowered the reservoir, it installed monitoring, it added piezometers. It built a bypass tunnel so water could move if another slide split the lake. It commissioned hydraulic model tests. This is what makes Vajont more disturbing than a simple story of blindness. The danger was not ignored because no one looked at it. It was measured until it seemed manageable. The bypass tunnel is worth pausing on. It was not built for ordinary operation. It was built because another slide could divide the reservoir and trap water on one side. That means the project had already accepted a future landslide as a design condition. The question was no longer whether Monte Toc might enter the lake. The question was how to keep the reservoir useful after it did. That is a narrow kind of caution. It protects the hydraulic system. It does not automatically protect the people below the gorge. The model test became central. At Nove, engineers built a physical model of the reservoir. They tested how a landslide might enter the water. They varied the water level and the imagined slide behavior. The goal was to find a safe operating level. The number that emerged was 700 meters above sea level. At that level, the model suggested the reservoir could tolerate the worst scenario considered in advance. Not harmless, not risk-free, but manageable. Here is the first hinge of the episode. A model is not a prophecy. It is a contract with its assumptions. In Vajont, one assumption mattered more than the others. The model landslide moved too slowly. It imagined a sliding time on the order of minutes, or in later analysis, still far longer than the real collapse. The actual mountain would move in seconds. The model also narrowed the picture in another way. It treated the landslide as a scenario to be selected, shaped, and released. The real mountain did not negotiate with the laboratory. It failed as one coupled mass of rock, water pressure, weak layers, and valley geometry. Once that happened, the reservoir did not receive a landslide. It was struck by one. That difference was fatal. Water does not respond only to how much rock falls into it, it responds to how fast the rock arrives. Pour a bucket slowly into a basin and the water rises. Drop the same volume suddenly and the basin throws it back at you. Vajont was that principle at mountain scale. By 1962 and 1963, the pattern was becoming hard to miss. When the reservoir rose, the slope moved faster. When the reservoir was lowered, movement slowed. When the water rose again, movement returned. ASDSO's case summary describes this pattern plainly. As the reservoir level increased, so did measured creep. By the summer of 1963, the reservoir reached about 710 meters above sea level. Movements increased. Another drawdown began. By October 4th, total movement had reached almost 8 inches per day. The project was no longer asking whether Monte Toc was moving. It was asking whether the movement could be controlled. That is a very different question, and it can be a dangerous one. Control language can make a warning sound like a procedure. Lower the level. Watch the instruments. Keep the water near the number the model called safe. Treat the moving mountain as a problem inside the operating plan. I am willing to argue that this is where the disaster became institutionally inevitable, not when the slope first moved, but when movement was accepted as something the reservoir could manage. Several days before the disaster, local officials issued warnings around Erto and Casso. Some homes were evacuated, not enough. Road traffic below the dam was restrained shortly before the collapse. Messages suggested that maybe a little water might pass over the dam that night. Nothing to be alarmed about. That phrase is one of the most important in the story, not because it proves malice, because it shows the size of event people were imagining. They were not imagining Longarone being erased. They were imagining water over the crest. They were imagining a smaller version of the known hazard. In the final hours before failure, the slope was moving fast enough to be visible. Cracks were widening in the road below the dam. Traffic on that road was being restricted. 20 technical personnel remained at their stations in the control center on the left abutment, watching instruments that were tracking a mountain in motion. The warning that reached people downstream did not match what those instruments were showing. At 10:39 p.m. on October 9, 1963, Monte Toc failed. The reservoir was near the supposedly safe level, about 700 meters above sea level. A mass of rock, commonly estimated around 260 to 270 million cubic meters, broke away from the mountainside and entered the reservoir. The timing was the disaster. Scientific reconstructions estimate the slide entered the basin in roughly 20 to 25 seconds. Other summaries describe it as less than 45 seconds. Either way, the mountain did not behave like the safe scenario. It arrived as an impact. The first wave climbed the opposite slope. Water and air surged upward toward Casso and Erto. The wave run-up reached hundreds of meters above the reservoir in later reconstructions. Then another part of the water moved toward the dam. It did not need the dam to collapse. That is the second hinge. The dam could survive and still be the center of the disaster. The wave overtopped the crest. Millions of cubic meters of water entered the narrow Vajont gorge below. The gorge became a chute. The flood rushed toward the Piave Valley in Longarone. On a map, the distance looks small. In the event, it was only minutes. ASDSO places the arrival of water in Longarone at about 10:43 p.m., roughly 4 minutes after the rockslide. 4 minutes is not an evacuation time. It is barely a realization. The water came out of the gorge with depth, speed, air pressure, debris, and force. Longarone was almost directly below the dam. The town had not been built inside the reservoir. It had not been built on the failing slope. It was downstream from a dam that did not fail. Pirago, Rivalta, Villanova, and Fay were also destroyed or severely damaged. Casso and Erto, above the reservoir, were struck by water, air blast, and debris effects. Technical personnel at the dam site died. People in buildings near the abutments died. The disaster moved both upstream and downstream because the reservoir was not a simple bowl. It was a narrow mountain geometry hit by a moving wall of rock. ASDSO notes that 20 technical personnel were in the control center on the left abutment when the rockslide occurred, and all of them died. 40 people were killed near the right abutment in office and hotel buildings high above the reservoir level. Those details matter because they break a lazy division between experts above and victims below. The underestimated event reached both. It killed people in the town, people near the dam, and people in communities above the reservoir. The failure was not only a failure to warn strangers downstream, it was a failure to imagine the scale of the event even at the center of observation. The casualty count is one of the places where the record needs care. UNESCO's Memory of the World page gives 1,210 deaths. Britannica writes that about 2,000 people were killed. ASDSO lists fatalities estimated upward of 2,056. Those numbers are not contradictions to exploit. They are a warning about precision. For the central count, the safest official number in this episode is UNESCO's 1,910, with other reputable sources rounded higher. The dam remained. Only the top portion suffered limited damage. The reservoir was never refilled. In the landscape today, that concrete wall still stands against the gorge, but behind it is the scar of the mountain. That image can mislead if we let it. It can make the disaster look like a miracle of engineering surrounded by bad luck. But the court record moved in another direction. The criminal proceedings ran through the years after the disaster. UNESCO now treats the trial archive as documentary heritage because it shows the human responsibility in the landslide and flood. The Italian Supreme Court of Cassation, in the legal summary available through the Disaster Law Database, confirmed in 1971 that Vajont was not a natural tragedy, but a disaster caused by negligence. 2 defendants were convicted. I read that legal summary beside the engineering summaries, and the same gap appears in both. The dam's strength never answered the question the valley was asking. Could the reservoir safely exist below that slope? Could a warning be issued in time if the slope moved? Could a model built on slower movement protect people from a faster mountain? Could a safe water level be safe if the assumptions behind it were wrong? These are not the questions a spectacular flood image answers. They are the questions that turn Vajont from a disaster story into a responsibility chain. First, a dam was placed in a valley where the reservoir slopes deserved deeper attention. Then warning signs appeared before and during filling. Then a smaller landslide proved the wave mechanism. Then monitoring and models converted visible danger into operational confidence. Then the actual slope moved faster and larger than the safe scenario. Finally, the warning to people downstream did not match the size of the event that arrived. That is the chain. Not one mistake, not one villain, a sequence in which each response narrowed the imagination of what failure could look like. The midpoint lesson is precise. Vajont was not a case where the dam was too weak. It was a case where the definition of safety was too small. That definition was built around a single object, the dam. The slope, the model, the water level, and the town below all entered the picture as inputs to whether the dam would hold. Once the dam was the object of safety, the rest of the valley became a variable. That distinction still matters because most viewers come to dam disasters expecting collapse. A cracked wall, a breach, a flood released through broken concrete. Vajont is different. It can stand while the project around it kills. The final hours were not a mystery in the usual sense. We know the time. We know the mountain. We know the reservoir level. We know the wave crossed the dam. We know Longarone was destroyed. The unresolved part is more uncomfortable. How many warnings does a system need before it stops calling the next step management? There were geological doubts. There was a local memory of movement. There was a nearby reservoir wave. There was the 1960 slide. There were measurements of creep linked to water level. There were model tests. There were last warnings. Yet on the night of October 9th, the downstream warning still imagined something smaller than the event. This is what the recurring visual should show: a map of the valley with one new layer added each time. The dam, the reservoir, Monte Toc, the ancient slide mass, the 1960 slide, the 700-meter line, the final wave path. Each layer makes the safety number look less like a solution and more like a narrowing frame. By the end, the viewer should not see 700 meters as a neutral measurement. They should see it as the line where confidence outran the model. There is no need to make Vajont more dramatic than it was. The facts already carry enough weight. A mountain moved. A reservoir translated that movement into water. The dam was not asked to hold, it was asked to forward the impact. The disaster did not begin at 10:39 p.m. It began when the reservoir was allowed to become the instrument for managing a slope that was already proving it could move. The record after Vajont does not say engineering failed because concrete cracked. It says engineering failed because the project made the wrong object the center of safety. The dam was watched as a structure, the mountain was treated as a variable. Longarone was left below both. That is the final contradiction. The wall held, the warning did not.